Hello, everybody. My name is Wouter Borsboom from TNO, and I will be presenting this presentation together with Leo Bakker. As David already told, my presentation about control, and we think it's a forgotten option in retrofitting. If you look into the Netherlands, I think there is a lot of achieved. Just to give an example, how long does it take to do a retrofitting? This is a project in Kerkrade in the south of the Netherlands. This is the original building built in the 60s, 70s. And in day one, we have a prefabricated facade mounted on the back side. In day two, we have a prefabricated facade in the front side. In day three, the roof is mounted, also prefabricated. And day 6 and 7, we have finishing zinc and roof trims, and day 8, the moving of the scaffolding. And we have zero energy in 8 days. I think this is really fast. If you look about energy consumption in the Netherlands, if you it's interesting to know how much energy does an average dwelling consume in the Netherlands in 15 years. This is about €42,000. That's a considerable amount. If you look into the development of retrofitting concepts, this is the project which is done in 2010, and to get zero on the meter, on the energy meter, there was an investment necessary of 130,000, and this including the bathroom, the kitchen, and the modernizing of the house. In 2011, that was also the pictures which I shown, a price was necessary of €100,000. And in 2012, the renovation to zero on the meter is about 80,000. So what you can see is that there's a reduction of the price, and this is including modernization, and it's going towards the €42,000. So there is a business case for retrofitting. But if you look at the 21 projects in the Netherlands towards nearly zero energy, how many houses use control? And if you look, for instance, for ventilation, only 3 out of 21 projects have control airflow inlets. It's a passive control to control the flow of the air. 5 have CO2 control ventilation systems. If you look to shading, the only thing which is available is a fixed overhang. And heating and cooling, most projects have central thermostat, not zoning. So, but why use control? I think there are 3 reasons to do control: health impact, to reduce the impact on health, improve comfort, so draft, overheating, and also too cold, and the third, that is to save energy. If you look, this is a research which is done by Berkeley Laboratories, and they looked at different materials and what the effect is on health. And these are DALYs, so lost years of health per 100,000 people. And if you look, for instance, for particle matter, you see that out of 100,000 people, 1,000 man-years are lost due to particle matters. And if you, this is Max Sherman, who is also conducting this study, and if you take out those with smoking, so that's the second-hand smoking and also the radon by smoking, the top 4 is particle matters, mold and moisture, formaldehyde, which is a building emission, and accrue, that is a product which is produced by combustion. If you look to control strategy, for particle filtration, you can filter outside air. This is a project which we do for a school, where we especially reduce the ultrafine particles. But for control, it's also possible to to focus on the cooker hood. This is a product of Bufa. These are multi-pass sensors, and what they can do is they can put the complete flow over the cooker hood, so to reduce emission. Now, other solutions are low-emitting materials and also dilution, but it's most related to odor. And these are some strategies to reduce energy, and this is the percentage reduction based on 1990 house. And as you can see, there's energy reduction possible by flow control air inlet, efficient fans, improve air tightness, that's in the order of 5%, demand control, that can be in the range of 5 up to 20%, heat recovery 15 to 25%, and the combination of control and heat recovery, you can have a reduction up to 30%. Also, control can also improve thermal comfort with shading, but also save energy. And these are 3 strategies. The first strategy is no shading, that is the red line. And what you can see here is the percentage below a given value. So as you can see that with the red line, no shading, some 95% is below 26, but there is a percentage above. And if you use shading and you use a light sensor of 300 watt, you can see that more percentage reach the given value. So there is an improvement in comfort. What is also done is that the solar gain in the wintertime is reduced. But by applying control on the indoor temperature, that is the green line, you can see that it is an improvement. And to show that here is these are the same strategies. What you see here is the cooling load, that's the green one, and here is in the red, there is the heating demand. These are different scales, so this is like 10 times more. This is a typical situation in the Netherlands, and this is when no shading is applied. You see there is a cooling load, and here's the heating load. And when shading is applied only with like a light sensor, you see an increase in the heating demand and a decrease in cooling demand. But the total is more than the first situation. And by controlling also on the indoor air temperature, you can see there is a reduction in cooling temperature, in cooling demand, but also heating demand stays the same. Another example is how people use the windows. And what you can see is the outside temperature here and the number of open windows. The purple ones are the Sundays and the blue ones are the Tuesdays. And as you can see, it's mostly depending on outside temperature. But what do you want? What's an ideal strategy? An ideal strategy is that you don't open your windows above a certain temperature, because then you have a cooling demand, and you don't want to open it below a certain temperature. And by introducing control for like opening windows, you can save energy. So the control is a dedicated balance. Here you see some of the actuators you have in a dwelling: ventilation, heating, cooling, shading, and electrical lighting. And here you have indoor air quality, indoor temperature, and indoor daylight. And as you can see, there is interaction between those aspects. What is interesting is that we can have a holistic controller which can do also weather prediction and is also model based. And what we want to control indoor air quality, light quality, and thermal comfort, and control the windows, the heating, the shading, lighting, and the ventilation. What we are now developing on the HERB project is an innovative control, and using weather data and also controlling different actuators. To give an example of what the control strategy is about, so here you see weather forecast, and you see hot hot days are coming up. If you use a conventional controller, you can see that temperature is rising in those hot days. But when we apply additional night ventilation to make it like extra cool, because we know a warm period is coming, and apply also the solar shading earlier, temperatures can be in between comfort levels. So this is some first tests we do. This is in Leo Bakker's house. And what you can see is some events where control is applied, and we use a Raspberry Pi with a video camera to monitor those interventions. And we are wanted to apply this in different retrofitting projects within Europe. You can find more information of case publication news on energy-led retrofitting on buildup.point.eu. And thank you all for your attention.